Assalamualaikum and hello to our beautiful lecturer, Madam Zari Sofia binti Othman. For our first task in this assignment, we choose to discover about the population growth in Egypt, a country in northeast of Africa and famous for its amazing ancient buildings like pyramids and old temples. Over the past few decades, Egypt's population grew rapidly, which leads to a lot of challenges and problems like housing and inflation. In this assignment, we applied the first order of differential equation to predict their population growth mathematically. We collected aerial data from 2004 to 2023, find the particular solution to calculate the population number and predict the future and past values of the population in Egypt. From this assignment, we can see that mathematical tools help us to make predictions of population in this reality world.
Based on figure 1, the population of people in Egypt is the highest in 2023 with 140,535,772 people compared to the previous years. According to the graph shown above, the population of people in Egypt increasing with time. Impressive government initiatives had contributed to the stable growth of population in Egypt that also resulted into better access of healthcare and improved their living standard. To predict a future number of population of people in Egypt in 2024, we will use these particular solutions. And we will substitute 20 into t. And after a few more calculations, we will get this value. As we compare the actual values of the population of people in Egypt in 2024, it is clearly that the predicted value has higher value than the actual one. To predict a past number of people of Egypt in 2003, we will use this particular solution. And then we will substitute the value -1 into t. And this is after we calculated. As we compared the actual value of people in Egypt in 2003 with the predicted one, it seems like there's slightly difference with the predicted one has the higher value. According to figure 2, the graph of a particular solution graph for the number of people in Egypt is directly proportional with time. When time is increasing, the number of people in Egypt is expected to be increasing too. Hence, it is predicted that the population of Egypt will be higher and keep on increasing in the future. We examined figure 3 and found that the estimated and real numbers of people increase rapidly. When we compare the estimated numbers to the actual values, we can see that there are variations. As a result, mistakes exist. And we think that several elements and reasons contribute to the data divergence. The actual value of the number of people in Egypt also increases, but not in the same manner as the particular solution. This is why there is a data deviation when comparing the graph of the actual and estimated number of the people in Egypt from 2000 to 2023. The Malthusian model can be used to explain the reasons for the inaccuracy of our results.
Although earlier models predicted rapid population growth, the actual rate has slowed down to several real-world factors. First of all, there's government interventions. In 2022, Egypt started a national project for development of the Egyptian family, also known as NDPEF, with support from the UN to help control population growth. The program teaches people about family planning, improve access to healthcare, and supports women in joining the workforce. By reducing unplanned pregnancy and helping women become more independent, the government hopes to create a better balance between population growth and development. In addition, there's also economic problems. Prices for food, rent, and healthcare have gone up a lot, and many people are struggling to afford basic needs. Central of Public Mobilizations and Statistics, also known as CAPMAS, reports that inflation has made things worse and unemployment is still high, especially for young people and women. Because of this, many avoid starting or growing a family since it's hard to manage financially. Third, there's also women's education and work. More women are going to college and starting careers. This has led to delayed marriages and smaller families. The fertility rate has dropped from 3.5 in 2014 and 2.85 in 2021. When women are more educated and have jobs, they tend to have fewer children, which helps slow down population growth. And the last but not least is migration trends. A lot of young people are moving abroad for better jobs, especially to the Gulf and Europe. This helps families through money sent back home, but it also means fewer people are staying to live and work in Egypt. Over time, this leads to slower population growth and can affect the country's workforce and economy.
All things considered, Task 1's goals have been completely met. We comprehend completely the application of first-order differential equations from MAT097 course to our project. Using this strategy, we were able to determine the increase in population in Egypt from 2004 to 2023 in Task 1. We computed percentage errors, or difference between the estimated based on the multi-share model and the actual values using the estimated number. Based on the value, we determined the causes of the values unfavorable comparisons. In addition, we need to identify the real factors that cause increase in population. One of the many benefits of Task 1 was that it allowed us to apply mathematical techniques, such as the multi-share model, which is derived from the first-order differential equations, to solve problems in a realistic manner.
Task 2.
Based on the question given, we need to approximate the integration of fx equals to ln in bracket of ln x in the power of 3 plus 5x in the power of 2 from the x equals to negative 4 to x equals to negative 1 using the Simpson's rule with 4 and 8 subintervals. First, we need to calculate with 4 subintervals. We begin it with calculating the width by using the formula here. And we got 3 over 4 as the answer. Then we would like to find the value of fx using these x values. After that, we times the fx values with the coefficients and find the sum value of them. Finally, we use this formula to find the final answer, which we got 2.744719. Now, moving on to our calculation with 8 subinterval. We begin it with calculating the width by using the formula here. And we got 3 over 8 as the answer. In the same method, we would like to find the value of fx using these x values. After that, we times the fx values with the coefficients and find the sum value of them. Finally, we use this formula to find the final answer, which we got 2.752621.
So now we already know how to use Simpson's rule on paper. So let's learn how to make it easier using Excel. So we're solving the integral equation, which is this, from x equal to negative 4 to x equal to negative 1. So first, we calculate the integral width, which is the h, using the formula which Wani just tell us just now. But we click it into the Excel, where we need to click the a minus b and over n. So we just put it into the formula and we will get the answer, which is 0.75. Next, we use the h values to find all the x values. As you can see here, from a equal to negative 4, we keep adding the h using this formula for the 4 subintervals. And for 8 subintervals, we will be using this formula on Excel. We calculate the fx using this equation that you can see on the screen. So we submit all the equation here, and then as shown here, we will find the coefficient from the 1 for the first and last, and in between it, we alternate it with 4 and 2. So we multiply each fx with its coefficients. As you can see here on the column D, we sum up everything. So the value, we will multiply it with h over 3 to find the final approximation. So we will repeat the same process with 8 subintervals, but just with more data. So here are our final answers. We rounded it to 4 decimal places. So now, let's move on to the graph. This curve visualizes the effects over our range. This curve actually it helps us to see how smooth or curvy the function is, which is why Simpson's rule fit it so well. So now look at this graph. This shaded area is the actual integral from x equal to negative 4 to x equal to negative 1. For the small dots, they show the values of fx at each subintervals. For 4 subintervals, we have fewer curves, meaning the approximation is a bit rough, but in the graph with 8 subintervals, the curve is smoother and huge. So the function more closely, giving us a more accurate result. So the blue shading shows that Simpson's rule is calculating. It's like connecting all the dots here with a gentle parabolas to estimate the area. So if we look at the percentage error, we will see that percentage from the 8 intervals is lower than 4 intervals. So what did we learn? So we see here the 8 subinterval result gave us a more precise value of area under the graph. So to conclude all, the more intervals we use, the better accuracy we will get. So the objective of task 2 have been accomplished. To find the integral of this equation, by using the Simpson's rule formula, we were able to explain why the value obtained was different from the actual value as a result of this situation. The number of subintervals plays a major role in determining the accuracy of the area. So, the higher the number of subintervals, the higher the precision of the value of the area. So, that's all from us. Thank you.